Today, it's my honor to present our work, Stochastic Dynamics for Video Infilling. The paper is a joint work of USC, Nanyang Technology University, and Columbia University. Task named Video Infilling. Video interpolation can generate transitional frames between consecutive frames with similar content. Video infilling hallucinates the possible frame sequence in long-term intervals. The applications of video infilling includes reconstruction of surveillance camera with low frame rate or missing frames restoration of vintage videos, live sports stream, or occlusion recovery. There are 3 challenges for our task. First, the inputs are sparse and discontinuous. Therefore, unlike video prediction, we cannot get initial momentum of the video sequence. Second, video infilling has to generate sequences that can smoothly transition to the end. The observation of the last frame becomes a long-term coherence requirement. Third, as shown in the image, long-term intervals that we need to generate possesses more uncertainty than shortened intervals. To model the dynamic under high uncertainty, our model uses reference module to first extract reference vectors from all observed frames. For each timestamp t, we infer the distribution p inference based on these reference vectors. Then, we sample a dynamic vector zt from the distribution. Finally, we use a decoder to generate the frame x tilde based on zt and previous generated frames. To train the model, we designed 2 kinds of losses. Pixel losses supervise the reconstruction quality of the generated frames. Dynamic losses make sure the inferred dynamic is close enough to the dynamic of the ground truth sequence. We compared our model with multiple state-of-the-art models on KTH, Stochastic MNIST, via robotic arm, and UCF 101. We also filled the gap for long videos in UCF 101. The inputs are 1 reference frames in every 8 ground truth frames.